evening, people of God from the entire Methodist community in all SADC region. This evening we've got Mr. Awonke Nqayiya. Mr. Awonke Nqayiya will be taking us through the paper 1 mathematics that will be written by the grade 12s on Thursday, and on Monday they will be writing their paper 2. So Mr. Awonke will be taking us through the revision that concerns mathematics paper 1. Mr. Awonke?
Yes, sir.
Are you ready?
Yep, I am.
Yeah,
Okay. Let me then share the screen. Hello, everyone. This is Awonke Nqayiya. I will be facilitating this lesson on the revision of paper 1 of mathematics. We will not be able to necessarily do everything. I think I will touch on the most important thing, which is the methodology that I would suggest that you use when you start maths, basically, be it it's paper 1 and paper 2. And then I will use a few examples from the exams that have been written before, a few examples to illustrate the method that I will share with you. So that will be calculus, which is the cubic function. And then I think we will take another example from sequences. If there is time, I think we will proceed to what comes after. Okay, I think that's algebra according to my plan. Okay, so I want to share the screen now, and it says only the host can share in this meeting. Can you please allow me to share?
Yes, sir, you are host. You are host, you can share.
But it says I can't share. It only the host can share this in this meeting. Hello, sir, are you winning? Oh, now it says I'm the host. Okay. Thank you very much.
Are you winning, sir? Did you manage to do it?
Yeah, it says I am the host now, so I can share.
Yeah, okay. That's fine.
Are you able to see my screen?
No.
Not yet, sir. We can't see your screen.
No, we can't see the screen.
Very interesting.
How is it interesting?
How about now?
Yeah, we can see now.
Okay.
We can see the screen. We can see the screen now.
Okay. No, sorry for that. My view of mathematics in terms of the idea that I said I will share with regards to starting maths. I think every question in mathematics, in order for you to be able to solve it successfully, you require a certain set of skills and then you use those skills to solve that problem. In maths, those skills can be defined as the basics, the foundation, the principles, those concepts that you learn in mathematics, then they combine themselves to form the skills to you. So they give you the knowledge. So every question requires a set of knowledge, and then that knowledge, you use it to solve some questions in mathematics. So my idea is that if you struggle to solve a mathematics problem, it's not because you are not smart, or it's not because you are not given the intellectual capacity to solve that problem. You actually can solve that problem. So if you are struggling to solve a mathematics problem, that means there are a certain set of knowledge or a certain set of skills that you are missing. So your duty then is to go back and learn those principles, learn those basics, and learn those concepts, and then come back and apply them in that question you were dealing with. So that is what we are going to do in this lesson. I will sort of give you the principles, the concepts, and the basics, and then we go and apply them in an example. So let's move forward. The first thing that I will do is calculus, which is when you deal with the cubic function, when you are given a question like that, which is f of x is equal to ax squared plus bx plus cx plus d. And then there you are required to calculate the values of a, the values of b, the values of c, and the values of d. So before you go there, there is a set of knowledge that you must know. So that is what I'm going to outline on this first slide. When you are given a cubic function, a graph like that, and then it is given on the Cartesian plane, there you are given the three x-intercepts. You have x1, you have your x2 as well, and then you have your x3. And then let's say you are given another point. Let's say that point is that point of inflection over there. Let's say you are given that point, let's say it's point P. And then you're given the x value there, and then you're given the y value as well. And then they want you to determine the equation of a cubic function equal to ax cubed plus bx squared plus cx plus d. So the approach that you can take there is the approach that will revolve around those x-intercepts. The method that we are going to take there is the one that involves those x-intercepts. So we have a formula that says f of x is equal to a, and then you say x minus x1, x minus x2, and then x minus x3. So that is another form of a cubic function. It can be expressed in that manner: a multiplied by x minus x1 multiplied by x minus x2, also multiplied by x minus x3. So this is the form that we use, especially when we have the x-intercepts, x1, x2, and x3. We have x1, x2, and x3. If that x1 is, let's say, minus 2, that x2 is minus 1, and that x3 is, let's say, is 4. Then on that expression there, f of x is equal to a. In the place of x1, we are going to substitute that minus 2. and that will become a positive 2. And then we say x minus x2, and then x2 is minus 1. So we will take that negative 1 and substitute over there. A negative by negative, that will give us a plus. So it will be basically a plus 1. And then we can take a guess, which value are we going to substitute at x3?
4.
Yeah, that is 4, because the third x-intercept is 4. And then what we need is to use that second point. Well, that another point, which is point P. We use that point P to substitute the value of y at P. We are going to substitute it at y, and then the value of x at P, we are going to substitute into the places of those x in that equation. And then from there, we press our calculators. For example, let's say the coordinate of P, x value is 1, and the y value is, let's say, is negative 2. So what are we going to do there is that in the place of y, we are going to substitute a negative 2. And then in the place of x, we're going to substitute a 1. That will become a plus 2, 1, a plus 1, a 1, a negative 4. And then by using that expression, we can then solve for A. I think from there, it's pretty straightforward to solve for A. So that is the method we use to calculate the values of A, B, C, and D when we are given the x-intercepts. So here we will solve for A, and then we will substitute that A back into that equation over there, the second formula, which means we will say, I don't know what is the value of A. Let me calculate. 1 plus 2, 1 plus 1, 1 minus 4, that gives us a negative 18. So from my side, we get negative 2, negative 18 times A. That means we divide by the negative 18. We divide negative 2 by negative 18 to get positive 1 over 9. So that is our A. So that is how we use that x-intercept format to determine the value of A. So we will come back then to that y is equal to A. In the place of A, we will substitute 1 over 9, and then we multiply out those 3 brackets there to get it in a cubic format. And then we substitute, we put that 1 over 9 inside the brackets. And then from there, we can see what is the value of B, what is the value of C, and what is the value of D. I think let me make an illustration for that. So we are saying that we come back to that y is equal to A. In the place of A, we substitute 1 over 9, and then x plus 2, x plus 2, x plus 1, and then x minus 4. And then from there, we multiply out those brackets to get something that is in a cubic format. For example, it can be x to the power 3, 2x squared minus 4x minus 1. It's not necessarily what we are going to get from the above. I'm just making an example. And then we multiply by that 1 over 9 to remove the brackets. So it will be 1 over 9, x cubed plus 2 over 9, x squared minus 4 over 9, x minus 1 over 9. And I think from that, it is clear that A is equal to 1 over 9, B is equal to 2 over 9, C is equal to negative 4 over 9, and D is equal to minus 1 over 9. So this is what we call the x-intercept method, because we used the x-intercepts. There's another method that we call a turning point method in order to calculate the value of A, the value of B, the value of C, and the value of D. So what we have discussed so far is the x-intercept method. And take note that the x to the power 3 plus 2x squared minus 4x minus 1 is not necessarily what you are going to get when you multiply out of those brackets. I was just making an illustration. So you may, well, definitely you will get something different from that. And then you remove the brackets by multiplying by that 1 over 3 inside the brackets to expand. And then from there, it's easy to see what is A, what is B, and what is C. Also, what is D. So are there any questions so far before we move to the turning point method? Because I want to discuss both of them before we go to this example.
Sorry, sir.
Okay.
Most to get to that 1 over 9, you said negative 18 divided by negative 2. Why do you put it in a fraction? Why do you say 1 over 9 instead of just 9?
I said, let me go back. I said A is equal to negative 2 over negative 18. And then when I press that on my calculator, I get a 1 over 9, not a 9. That's why I did put it as a 1 over 9, not a 9.
Okay, sorry, sir. I swapped them around. Okay, thank you, sir.
Okay, oh, I thought I'm wrong. Thank you very much for the question. I enjoy the questions because the more we engage, the more we learn.
Sir.
Okay.
So from the graph, there's like on the actual graph, it's -2, ne? So like like on the of the x-intercept method, does it change to be a positive 2?
Yep, that's a very good question. You see, the x-intercept method has negatives between the x values. Can you see that? So yes, when the x value, which is x1, comes with a negative, then you will multiply that negative of the x value with the negative of the formula, and then you get a positive.
Okay, thank you. Because a negative times a negative is a positive, right?
Yep, a negative times a negative will give you a positive.
Can you please explain it again, sir? I didn't get you.
Okay, no problem at all. You see, we have x minus x1 on the formula, and then it appears that the x1 over there from the graph has a negative, which is -2. So when we substitute at that x1 with that -2, we will say the negative at the formula multiplied by the negative of the 2.
Yeah.
And then the negative times a negative will give us a positive. Hence, it will become a +2 there.
Oh, yeah.
So you get it now?
Yeah, I get it now.
Okay, no, that's good. So this is what we call the x-intercept format. Another thing that you have to be careful of when you deal with when you are given the x-intercepts is that sometimes the graph that you are going to be given will have a turning point at an x-intercept. For example, I'm going to draw it with a red line. For example, we are given that, can you see that red line? There's something interesting now, if you can look at it clear. How many x-intercepts do we have now? Just take a guess.
Two.
We have 2 x-intercepts.
2, sir.
Yep, that's a very interesting case, because that means now x1, there is only x1 and x2. There is x1 and then there is x2. The x's that I have written with the red marker. There is x1 and there is x2. So when we come to that x-intercept format, there is a catch now, because there we need 3 x-intercepts, which means we need x1, we need x2, and we need x3. So what can we do there is that when a graph turns at an x-intercept, which means in this case x1, that x-intercept, you use it twice, you use it 2 times. So that x1 that you have on that graph, you will substitute it on that equation 2 times. You will substitute it there, and then you will substitute it at x3. So you use that x1 2 times. At x1, you will substitute the x1 written with the positive mark, with the red mark. And then x2, you will substitute x2 that is written with the red mark. And then x3, you will substitute that x1 again. Why do we substitute that x1 2 times? It's because the x-intercept, which is x1, is also the turning point of that cubic function. That is the reason why. Did you get that reason? Because it's very important. It might come up in the upcoming questions. Do you get why we use x1 2 times?
Yes, sir.
Yeah, we are going to substitute at x1 by the red x1. We are going to substitute at x2 using the red x2. And then we're going to substitute at x3, substitute x1, because we do not have x3. So we're going to substitute x1. The reason why we choose x1, not x2, it's because x1 is a repeated x value there. It acts as an x-intercept, and also it acts as a turning point of that function. That's why we use it 2 times.
Sure.
Let's come to, okay, okay, any question?
Yeah, I have a question.
Okay.
You said you substitute x1 into x3. So does it have to be exactly the x1, or is it negative of x1 and positive of x1?
Exactly the value that you have at x1.
Okay.
If x1 is -1, then you're going to substitute -1 2 times.
Okay.
So let's come to this question that we have. It's an exam type question, basically. So let us read that question. There we are told that the graph of f of x, which is ax squared, ax cubed plus bx plus cx plus d, and the graph of g of x, which is the straight line, are sketched below. And then there we have 2 points, point A and point C, which are x-intercepts. There is point A and there is point C, which are x-intercepts of f. And then we are told that D is the y-intercept of f. Also E and D are points of intersection of graph f and G. That is E and D. So the question is to determine, or well, whether to show A is 2, B is -2, C is -10, and D is -6. So what do you see over there when it comes to the x-intercepts? What do you see? Is there anything familiar with that one?
Yes.
Okay, what do you see?
I see A as a point and as a turning point.
Yep. A there is repeated, basically. It acts as an x-intercept of that cubic function. It also acts as a turning point of that cubic function. So when we want the values of A, B, C, D, and E, well, we don't have E, we are going to use that f of x is equal to ax minus x1, x minus x2, and x minus x3. The reason why we use this formula is that we have now the x-intercepts. A there is an x-intercept, C there is an x-intercept. So that is why we go into that formula, which is the x-intercept method. And then we say y is equal to A x minus, what do you think we are going to substitute at x1? What are we going to substitute? We are going to substitute that x value at A, which is the x-intercept of that cubic function. X there is -1. So we take that -1, the minus of the formula multiplies with the minus of that x value, and then it gives us a positive. So it becomes a +1. What do you think we are going to substitute for x2?
3.
Sorry? Yeah, we're going to substitute 3 over there. We're going to substitute 3 over there. What do you think we're going to substitute for x3? This is the interesting part.
+1.
Yep, we're going to substitute 1 again. So you go to that A over there, because that A is the x-intercept of that cubic function. It is also the turning point of that cubic function. So when it acts as two things of that cubic function, then you use it 2 times. Then we're going to take that -1, substitute it over there. So the negative times a negative becomes a positive. Hence, we're going to have a +1 over there. So what do you think is the next step?
Substitute a point from the graph.
Yeah, we are going to check for any other point that is given on that graph. Remember the sketch that we had earlier, we had point P, which was given as 1 and -1. Now we have another point on this cubic function that we are working with. The point is D. The y value there is -6. And then the x value is 0. The x value is 0. The x value is 0. And then we multiply out all of those 3 brackets to get a -3, I think. Hopefully my maths is right. And then we divide by that -3, we divide by that -3 to get A, which is equal to a 2, right?
Yes.
Yep.
Yes, sir.
And you can see we are trying to show that A is equal to 2. And we have done that so far successfully. A is equal to +2. So the next part is to determine the values of B, the values of C, and the values of D. What do you think we should do?
We substitute the A back into the equation.
Yep. We come back to the equation, just the second equation, y is equal to A. There we place the value of A, which is equal to 2, and then x + 1, x - 3, x plus 1. And then we multiply out to x times x. So firstly, we deal with the first two brackets. Firstly, we deal with the first two brackets. We will come back to the third one later on. So x times x, that is x cubed. That is x squared, I mean, x times x, x squared. 1 times x, that is, okay, my pen is not writing. Basically, 1 times x, that is x. Okay, my pen is not writing. So 1 times x, that is x. X times negative 3, that is 3x. And then 1 times negative 3, that is negative 3. And then you multiply with x plus 1. Y is equal to, and then you clean the brackets, the interior of the brackets, you collect the like terms to get x squared minus 2x minus 3 x plus 1. So this is the step. These are the steps that we skipped out on the previous example because it's a little bit long. And then we try and multiply the two remaining brackets now. Remember, we had a bracket that we left out earlier. So we're going to multiply out those two brackets to get only 1. So x times x squared, that is x cubed. X squared times 1, that is x squared. And then negative 2x times x, that is negative 2x squared. Negative 2x times 1, that is negative 2x. And then you use the negative 3. Negative 3 times x, that is negative 3x. And then negative 3 times a positive 1, that is negative 3. Okay, I'm running out of space now. But let us clean the interior of the brackets. Let us collect the like terms. That will be x cubed. Is there any brave learner that would like to give us the interior of those brackets, the cleaned version?
X cubed minus x squared minus 5x minus 3.
Can you be a little bit slowly?
X cubed minus x squared.
Okay.
Minus 5x.
Okay.
Minus 3.
Minus 3. That's good. Thank you. Hello guys, can you hear me?
Yes, sir.
Oh, okay.
Yes.
Sure. My laptop died, so that's why I went out quickly. So now you can hear me, you can see the screen as well.
Yeah.
Okay, no, that's good then. We are back at it. So after this step, you are going to multiply out those two brackets. The 2 will multiply the x cube. The 2 will multiply the x cube. Then the 2 will multiply the negative x squared. The 2 will multiply the negative 5x. The 2 will multiply the negative 3. So that is what we are going to do so that we get to see the values of A, B, C, and D. I'm running out of space. So that will basically be y is equal to 2 times x cubed, that is 2x cubed, 2 times negative x squared, that will be negative 2x squared, followed by negative 10x, followed by negative 6. So can you see that from the original equation that we were given, we had this function in terms of A, B, C, and D. And then now we have it in terms of the y is equal to 2x cubed minus 2x squared minus 10x minus 6. So you can see from there that, okay, A is negative 2, B is negative 2. Well, A is positive 2, B is negative 2, C is equal to negative 10, and then D is equal to a negative 6, which is what we were trying to show basically on that 9.1. Is everything clear so far, or are there any questions?
Everything is clear.
Any questions? I like questions. Please don't hang on me when it comes to questions.
No
Don't
questions,
laugh at
sir.
me when it comes. No questions.
Yeah.
No questions.
Okay, that's good.
I will.
So let's move to 9.2, which is calculating the coordinates of the turning point at B. I think there is someone that is unmuted. And there are taxi drivers around. Can you please mute yourself?
Sir.
Oh, that's
Yeah.
fine. That's fine. Sorry, you wanted to say something?
Yeah, I have a question.
Okay,
So,
that's good.
Okay, fine. We've proven that A is 2 and blah, 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 blah. You find that. Is it fine if you just take it back to the simplest form where it's just the interior bracket?
Is it fine if?
Because like there's a common factor of 2, right? If we divide everything by 2, then we're gonna have x cubed and we're gonna go back to the interior bracket.
You want us to divide by 2?
Yeah.
So we have y is equal to 2x cubed minus 2x squared. What else? Minus 10x minus 6. So what is your question?
So from this equation, we can see that there's a common factor of 2.
Okay.
So what if we divide everything by 2, then we left with that simplest thingy? Because we can still
left with x cubed.
That's impossible. We can't divide by
minus
2.
X squared minus 5x.
We can. 2 is the...
Look at the
want it to
question. The
appear
question
that way.
says show that A is equals to 2, B equals to negative 2, and C is equals to negative 10.
I'm saying for
and
9.2, can we just do that? For 9.2.
Can we do this one? Sorry? For 9.2.
Because you know sometimes when we have something like that, we have to divide. It's fine, sir. You can drop it. It's fine.
Well, let me then answer your question. She's correct by saying that you are not allowed to do that because you are basically removing an element of this function by dividing by that 2. You mentioned that 2 is a common factor. So the good thing that you would do is to take out 2 as a common factor, not necessarily divide by it, just take him out as a common factor. Let me just, you see, when you write it in that manner, it's mathematically correct. You just took out the 2, which is a common factor, and then you got the interior in a simplest form. But nonetheless, you have to multiply by that 2 inside the brackets to see what is the value of A. Okay, you wanted to ask something?
No, it's fine. So the question has been answered.
Okay.
So in which case do you have to take out the 2?
In which case do we have to take out the 2? When we, let's say we want to determine the y-intercept, right? When you want to determine the y-intercept, you let y equal to 0. Is that the case, or am I wrong?
Yes, sir.
And then when you equate that expression, let me put it this way. When you equate that expression to 0 to solve for x, then from there you can say, okay, this is a little bit complicated for me because it has 2 next to that x cube. So let me divide by that 2 right through. So you will divide the 0, you will divide the 2x cube and get 2. So you will divide first the 0 by 2 to get 0, and then you divide the 2x cube by 2 to get an x cube. You divide another term to get an x squared, you divide another term to get a negative 5x, another one to get a negative 3. This becomes simpler for you, let's say maybe that is the case. So that is when you are allowed to divide by that 2 or that value of A. When you are going to divide on the left-hand side as well. Remember, what you do on the left, you should do it even on the right. What you do it on the right, you should do it on the left as well. Is that clear?
Yes, sir. Okay.
So can we move to the next question?
Yes, sir.
Yes, sir.
Okay. There we want to calculate the x in the coordinates of the turning point. I think this session was scheduled to end at 7:30. So now it's 23 minutes past 7. So we have 7 minutes left. You see, we didn't cover that much. The thing is, it's a very short space of time. And I like to make sure that before I go to another thing, it's clear what we have done. So you will forgive me on that note. So when we calculated the coordinates of the turning point of a cubic function, we have to first derive the cubic function, the equation of that cubic function. Who can give us the derivative? The first derivative. Who can he give us the first derivative?
6x
First
squared.
derivative is equal to 6x squared.
Okay.
6x
minus 4x minus 10.
Yep, that is the first derivative of that cubic function. And then the second step is to equate that cubic function, that second derivative to 0. The reason why we equate that first derivative to 0 is that the first derivative of a cubic function is the gradient of a tangent. And the gradient is equal to 0 at a turning point. If you see that, that red line that I'm sketching over there, that is the tangent at a turning point of a cubic function. So that tangent over there has a gradient of m is equal to 0, or it has a first derivative, because a first derivative is also equal to a gradient. So the first derivative of a function is also equal to the gradient of a tangent to that function. So the tangent at a turning point, it's a constant function, meaning that the value of the gradient is 0. That's why we equate that equation to 0, because the gradient is 0. Then from there we solve for x. You see, this is where you can be able now to divide by that 6, because you're solving for x. So you can divide by that 6 if you like. You can use a quadratic formula if you like. You can find factors if you like. Can you please calculate on your side whether to use quadratic or you use a method of factors? It's up to you. Can you calculate on your side and then give me the values of x?
Yeah, use the quadratic formula.
Sorry? I didn't get you.
When I use the quadratic formula, I got x is equal to 5/3, and then subbing it in back to the original thingy, it's minus 512/27.
You got x. You should get two values of x.
Yeah, x is 5/3 and x is minus 1.
X is 5/3.
And x is minus 1.
Or x is minus 1. So
Right.
this is where you go back and observe the diagram that you were given earlier. Reason, what is the value of what is the sign of the x value at b? Do we expect x at b to be positive or to be negative?
X is positive.
Positive.
Yeah, x is positive,
No,
and
X
then
is
we use that
positive.
5/3.
Oh,
Hence,
yeah.
we use that. Yeah. Okay. You were saying something. You were saying it's negative.
No, positive.
No,
Yeah, it's
X is
positive.
positive, Y is negative.
Yep.
It is positive.
Yep. And then hence we are going to use that x is equal to 5/3, not that x is equal to -1. If you can see that -1 is over there at A. Remember, we said A is the x-intercept, but at the same time, it is the turning point. So that is why now we get to find that, okay, x is equal to 1 shows up as well as a turning point. So we then go back to the original equation, which was 2. In the place of x, there we substitute 5/3. That is cube, not square. We substitute 5/3 in the place of x. We substitute 5/3 in the place of x. We substitute 5/3. So what do we get for y?
Minus 512/27.
Minus 512/27. So your coordinates of the turning point, which is B, can be written in that way: 5/3 and minus 5. My pen is playing games with me. 512/27.
Yeah.
So that is the turning point of that cubic function at B, the coordinates. I think the time is 7:30. I don't want to keep you long. We didn't do that much, but I hope that you learned a thing or two from what we have done.
No, so we don't mind. We can go till 8.
Sorry?
We can go till 8. We don't mind.
We don't mind. We still have time, unless if you don't.
Okay. We have a different kind of learners here. That's nice. So is everyone okay with that?
Yes.
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 Okay.
Yes, sir. Yes. Yes. Let's stay longer.
Yeah, because you're still enjoying.
It's nice to be here.
Yeah, it's nice to be here.
That's fine then. That's fine. That's fine. I think we can proceed. Remember, I told you that there are two methods to calculate the values of A and B, C, and D. And the method that we have discussed so far is the x-intercept method. So there is this x-intercept method, we use it when we are given the x-intercepts of a cubic function. We are given A, which is the x-intercept. We are given C, which is the x-intercept as well. Sometimes you will not be given the x-intercepts. You will be given the turning points. Now, when you are given the turning points, you then use the turning point format or the turning point method. Have you seen a scenario whereby you use a turning point method, or is it your first time you hear about that?
Oh,
We've seen it.
I've seen it.
You have seen it, right? That means you're a little bit ready. That means you're probably ready, I mean, for the upcoming exams, because you shouldn't be surprised now at this stage when I talk about a different thing. So should we do the, okay, let me do it. Just to illustrate. We are done with that question. Just to ensure that we cover both examples. I did not upload it here. So please bear with me, I will have to draw it. But it shouldn't take that long. Are there any questions related to mathematics, regardless of cubic, calculus, or whatever? Are there any questions, something that you would like to ask while I'm still busy drawing? Any questions?
Sir.
Sure.
Is there going to be like another lesson for paper 2?
Yes, we are planning to have another lesson probably on a Saturday. We want you to rest after Friday. Then we probably have a lesson on a Saturday on paper 2.
Could you guys please like increase the hours, like give us at least 2 hours for theme?
Okay. Now I will submit that request. Definitely I will submit it.
Thank you, sir.
So you are longing for paper 2. Okay.
With the cubic function, if you're not given the intercepts, how do you find AP and how do you find A, B, C, D?
If you are not given the x-intercepts.
Yeah.
You're saying something like this one that I'm drawing here, right?
Yeah.
Okay, we are going to talk about that just now.
Okay.
Any other question?
Sir.
Okay.
Can you please do probability? Like, can you explain the counting principles?
I don't think we will have time for today. Maybe we will have to organize another lesson for tomorrow.
Yes, please, sir.
Okay. Now I will talk to the organizers of these lessons. And I'm just the visitor. I come in and I leave. So I will talk to the organizers and submit your requests. That of paper 2 and also that of that of ours and also that of probability. Any other question, or should I dive into this example?
No question.
Okay, Dolor, that's fine. Here, we are given the function, which is f of x is equal to negative 2x squared, 2x cubed plus ax squared plus bx plus c. That's a cubic function and it is cached. And then the turning points are given as t. We have the coordinates and we're given another turning point, which is s, and we have the coordinate. So the first question here is to show that the values of a, b, c are given by those values, which is 21, b equal to 60, well, negative 60, and c equal to 45. So if you look at this example now, it is quite different from the one that we dealt with before. And I promise that you will see only two of these. You will see this kind of example, or you will see the one that we dealt with previously. So you will not see any other variety of an example. I promise you that when it comes to determining the values of A, the values of B, the values of C. So if you understand the one that we did, and then you understand the one that we're going to do, we are sort of covered when it comes to the question of determining the values of parameters that are in the equation of that function. So if you observe here, we are given the turning points, not the x-intercepts. We're given the t and we're given the s, which is the turning point. Now, that means we're not going to use the x-intercept format. We are going to use the principles of the turning point. So once you see a turning point, you remember on the previous question, when we were dealing with the turning point, which is B, when we wanted to calculate the x value there, or when we wanted to calculate that coordinate B, we had to derive that function. So we are going to use the same principle even here. Our principle will be derive the function that you have, which is that f of x. So f of the first derivative of x, is there any brave learner that wants to take that one? How do we derive? What is the derivative of f of x?
Negative 6.
Any brave learner? Negative 6x squared.
Yeah. Plus 2ax.
Plus 2ax.
Plus b.
Plus b. That's nice. Now, we are going to use that derivative of f of x. We're not going to focus on f of x, but we are going to focus on the derivative of f of x. The reason for that is because we are given the turning points of that f of x. So how we work with the derivative is in this way. You remember earlier when we were calculating the coordinates of B, I will refer to this example more often. When we were calculating the coordinates of B, what we did is that when we wanted the x values, we equated the first derivative to 0. So that is what we are going to do even on that case. We are going to equate the first derivative to 0. But now it is quite different. We equate the first derivative to 0, we say negative 6. Now we are not solving for x because we already do have the x values. The first x value is positive 2. The second x value is positive 5. So we are not calculating those x values. That is why we are not going to solve for x. We are going to substitute in the place of x by that x value. The x value at t is 2. So we're going to take that 2, substitute it in the place of x. Take the 2, substitute it in the place of x, and then we get the first equation. In the place of x, we substitute 2. In the place of x, we substitute 2 plus b, And then when we simplify that, that will be negative 6 times 2 to the power 2, negative 24, plus 4a plus b. So this will be your first equation. Your first equation is in terms of a and b, if you can look at it carefully. It is in terms of a and b. So we have to find another second equation that will be in terms of a and b, and then we solve those two equations simultaneously. Remember, we have used the turning point t. There's another turning point that we have not used, which is that s. We are going to use that s now, using the same method. We will equate the first derivative to 0. We say negative 6. Now in the place of x, we substitute 5. In the place of x, we substitute 5 plus b. 0 is equal to 6 times 5 to the power 2. I think that will be negative 150 plus 10a plus b. That will be your second equation. Your second equation, if you can look at it clearly, that second equation is also in terms of a and b. So you will use that second equation and that first equation to solve for a and b simultaneously. So that is how you get to determine the values of a, the values of b. When you have a turning point, when you have turning points, you find the first derivative, you equate it to 0, and then you substitute the x values at the turning point. Remember, we substitute only the x values. We do not take the y values. In the place of 0, you do not substitute by that negative 9. You do not. You take only the x value at the turning point. You substitute it in the place of x, and then you equate that to 0. To get your first equation, you take another x from the turning point, you substitute it over there to get the second equation in terms of a and b. Then from there, you use these two equations to solve for x and y simultaneously. So let us solve it. Solve for x and y simultaneously. We have the first equation 0 equal to negative 24 plus 4a plus b. That is the first equation. So which variable do you think we should make the subject of the formula there? Which is the easiest?
B.
B, we are going to say B is equal to 24 minus 4a. 24 minus 4a. So that is B, the B that we have. And then we are going to take that B, substitute it to the second equation. On the second equation, we have 0 minus 150 plus 10a. In the place of B, we will substitute by 24 minus 4a, 0. And then we say minus 150 plus 24, we get a negative 126. 10a minus 4a, we get a positive 6a, which becomes 126 equal to 6a. And then we divide by that 6, which is 126 over 6, which is equal to 21. Are there any questions so far? I don't want to leave any learner behind. Make sure that you stop me even in the middle of a conversation.
So is this another way of finding the equation?
Yep, this is another way.
Okay, thank you.
This is the method that you remember earlier we were given the x-intercepts, right? Do you still remember?
Yes, sir.
Earlier we were given the x-intercepts, but now we no longer have the x-intercepts, we have the turning point.
Okay.
The point S and the point T are the turning points of this cubic function. So we have to use another method when we have the turning points. We do not have to use the x-intercept method. It's not going to work in this case because we do not have the x-intercepts.
Okay, thank you, sir.
Okay, just briefly to go back and sort of emphasize how this method works. Since you have the turning points, you have to first find the first derivative of that function f of x. That is what you do. You find the first derivative, and then you get a negative 6x squared plus 2ax plus b. So that is your first derivative. The reason why we find the first derivative is that when we deal with the turning points of a cubic function, we always use the first derivative. You remember earlier, we calculated the coordinates of B, which is the turning point. Before we calculated that turning point, we found the first derivative, which means anything that revolves around a turning point of a cubic function, it includes the first derivative of that cubic. So now we have turning points, then we find the first derivative. We equated the first derivative to 0 because that is what we did even before when we wanted the coordinates of B. We equated the first derivative to 0. We're going to do the same thing. So we equated the first derivative to 0, even in this case. But now the difference is that we already have the x value at the turning point. So we're not going to solve for x. We are actually going to take that x value at the turning point, substitute it there. Negative 6x squared will be negative 6. In the place of x is 2. Plus 2 times a in the place of x is 2 plus b. The reason why we substitute that 2 over there, it's because the x value at the turning point is 2. And then you simplify that, you get your first equation in terms of a and b. Remember, we have used the first turning point, which is t. That means let us use the second turning point now, which is s. So we do the same thing, first derivative equal to 0. And then in the place of x, you substitute the x value. We are no longer solving for x. We substitute the x value because we do have that x, which is x is equal to 5. We substitute in the place of x by 5. By 5, you cleaned out that equation. You get the second equation in terms of a and b. And then you use these two equations that I have sort of underlined with the red line. You use those two equations to solve for a and b simultaneously. So we took the first equation and put it over there. And then from there, we made b the subject of the formula. And that is b equal to 24 plus 4, 24 negative 4a. That means we took that negative 24 from the right to the left to become a positive 24. And then we took that positive 4a from the right to the left to get a negative 4a. Hence, b is equal to 24 minus 4a. And then we substituted this b to the third equation. There is the third equation over there, negative 15 and blah, blah, blah. So 0 is equal to negative 15 plus 10a plus b. But b now in this case will be that positive 24, that positive 24 minus 4a. So that is our b. We substitute there for b. And then the equation is in terms of a. we clean out, we collect like terms, we say minus 115 plus 24 gives us a negative 126, plus 10a minus 4a gives us a positive 6a. And then from there we solve for a, we get that a is 21. Are we together so far, or are there any questions?
No questions.
What is everyone else saying? Any questions?
No questions, sir.
Okay, let us proceed then. So now we do have the value of A. What do you think we are going to, how do you think we are going to determine the value of B?
Substituting the answer of A into the B equals to 24 minus 4A.
Yep, B is equal to 24 minus 4A. That's a very good answer. A is 21. So what do you get when you press on your calculator?
Negative 60.
Negative 60. It seems like we are on the right track because remember, we wanted to prove that A is 21, B is negative 60, and C is equal to 43. So the only missing at the moment, the only missing variable is that, that C. So f of x is equal to 2x cubed. What is A? And remember, 21.
21.
What is B?
Negative 2x cubed.
What is B? Negative 60. It's negative 2. Yeah, that's correct. Negative 2. My pen is playing games with me. Negative 2x cubed plus, what is B?
Negative 60.
Negative 60.
Plus C. So is there anyone that wants to take a guess now? How do we think we're going to determine the value of A?
We're going to take a point and substitute it into the formula.
Yep, we're going to take a point, and any point that you have on that graph. It can be the turning point, it can be the x-intercept, it can be the point of inflection. So which one do you want us to take?
518.
Yep, we will take S. You can take T, it's fine. Let's just take S. So the X value is 5 and the Y value is 8. Is 18, I mean. So we substitute 18, negative 2. The X value is 5. 21, the X value is 5. The X value is 5, and then you solve for C. Is there any brave learner that wants to calculate this value of C?
$43. C is 43.
C is 43. So it's a simple algebra to move from there to C equal to 43. It's a very simple algebra. I don't think you will struggle with that. I trust you well. Well, it's only 5 minutes. So, yeah?
Can you please, I want to see the steps, or how did you get 43?
Oh, okay. Hi. That's fine. That's fine. So we have 18. So you press it on your calculator. There is negative 2 times 5 to the power 3. For that, you get a negative 250. And then there is 21 times 5 squared. For that, you get 525. And then there is 60 times 5. For that, you get negative 300 plus 3. And then you sort of press the whole thing in a calculator.
Okay.
Minus 250 plus 525 minus 300. And then
It's
you
negative
get
25.
Negative 25 plus C. And then you take that negative 25 to the right and it becomes a positive 25. So 18 plus 25 should be equal to C. So 18 plus 25 should be equal to 43. Are you happy, my man?
I'm happy, sir.
Excellent.
Thank you.
Are there any questions with regards to the methods that we have discussed? The two methods, the turning point method and the x-intercept method. Are there any questions?
Sorry, sir.
Okay.
If we substituting 2 from the point T, would we get the same answer?
If we substitute 2 and negative 9.
Yeah.
Yes, I bet we would. Let me see.
Confirm.
Yes, we will get it.
Yes, we will.
Yes, you will get the same answer.
Yeah, I did that method.
Any other question? Next question. I love questions, so please bring them along. The more we engage, the more we learn. Any questions?
No, sir. I think we may proceed to the next question if we do have it.
Okay. Well, I don't know whether we should proceed to the next question because there are only 2 minutes left before 8.
Oh, thank you so much, sir.
This was really appreciated.
Sorry?
This lesson was very productive. Thank you very much for taking our time to teach us.
Okay, yeah, I think this is the time of feedback.
Please let us know when there's another lesson tomorrow, please.
Yes.
Please.
He's gone.
Yes, man.
Thank you, sir.
No, I'm still
Just
around.
like that.
I'm still around.
Yeah, please let us know, sir.
I'm still around. How can you say I'm gone?
I
just wanted to show my face.
Wait, how do we know about these lessons?
Sorry?
How do we get to know about these lessons?
How do you get to know about these lessons? Very interesting question.
How will we get informed?
Well, let me just write my number here.
Dango.
Because I do upload the links on my WhatsApp status. Then from there you can see that, oh, actually there's a lesson.
Dango.
So my number here.
Don't worry.
Okay, no, I will upload it.
Dango.
There it is.
649118183. Dango.
This is a hospital, man.
So you will be updated there with regards to the lessons.
So please write the number again.
Again?
I didn't see your.
It's in the chat. Oh my God.
In the chats.
How do we?
You press chat, then you will see the contact details there. Very simple. ABC.
Algebra.
Okay, yeah, that's all from me.
Are you a teacher?
No. I'm not.
What do you do? Do you just write math books?
Sorry?
You just write math books?
Yeah, I just write math books.
Wait, where do you live? Maybe you know my teacher.
I'm from Tzedane in the Eastern Cape.
I thought you knew my teacher.
Yeah, around Butterworth.
I thought you knew my teacher.
Okay, so I think this is the information that was left out in the introduction about me. Hence, you ask if I'm a teacher.
How? Carry on.
My name is Awonke Nqayiya. I'm coming from Tsendane, which is in the Eastern Cape. I'm currently at Nelson Mandela University. I'm studying mathematical statistics.
Yo.
So I'm not studying education. I'm doing masters in mathematical statistics.
So you genius.
So normally I use my free time to
week to week.
I assist high school learners.
Okay.
I assist high school learners. So that is how the study guide came about, which is study guide titled Mathematics with Nqayiya. You can recommend it for grade 11 learners and grade 10 learners that will be doing grade 11 and 12 next year. So that's me. Any questions?
No, sir.
No questions. So we're just waiting for tomorrow's lesson.
Okay. If there will be one, but I will do submit a request.
Make sure that you make one.
No,
please.
Sorry?
After hours, sister.
So could you please just make a group chat so that you can inform us when you do these videos?
No, you ask him a question. You have his number now.
No, but he's not going to save my number, all of our numbers.
Yeah.
And in order to see somebody's status, they have to save your number.
Oh, correct.
Yeah, I think it's a good idea to make a group chat so you can inform us.
How do I get your? Oh well, no, you can just inform me. Just WhatsApp me on that number. Then when after let's say 2 hours or so, I will, assuming that I have received all your texts, I will create a WhatsApp group.
Thank you, sir.
Thank you, sir.
Enjoy dinner.
Thank you, sir. Enjoy your dinner.
Sure.
Week to week.
Bye, guys.
Bye, sir.
Sure, sir.
Students are happy.
Fade, sir, fade.